Hello everyone. This video is on the Knewton Alta assignment for section 7.2 called Factoring Trinomials with a Leading Coefficient of 1. In this video I'm going to be doing a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment on your own. But the objectives are the same, the structure should be similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment, on your own. Alright, so on the assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. Looks like there are 3 objectives here. Under the current objective there should be a question related to that objective, and at the bottom of every question you should see a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Alright, this is for instructors only. But you will have a more instruction button. If you're ever struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright. So in this particular assignment we're looking at special kinds of trinomials, right? I know it says factoring trinomials with a lead coefficient of 1, but not just any trinomial. Alright, we're going to be looking at degree 2, specifically degree 2 trinomials of these forms. Alright, the forms that are in the objectives here. So I'm going to write out those forms that they have on a piece of paper actually, and talk about how to factor them. Alright. So the trinomials with a lead coefficient of 1, these special trinomials that we're going to be factoring in this video, are the following. So trinomials, again, very special, very specific kinds with leading coefficient 1. And we're, again, factoring these things, and hopefully, you know what that means, right? When they say factor something, that means take the expression and rewrite it as a product. Now, before I get into these specific forms, I'll tell you this note right now. The first step you should be performing when factoring is finding the greatest common factor. The first step in factoring an expression completely and this is any expression, not just these trinomials. Alright, the first step in factoring an expression completely is to factor out the greatest common factor, the GCF, which in sections, the section 7.1 assignment talked about the GCF, greatest common factor. Alright, and I'm just going to put this in a little bubble, a little cloud. Alright, this is, just keep this in mind. Alright, just keep this in mind. Now, if the terms don't have a common factor, then you don't have to do this. But this should be the first thing you look for anytime you're asked to factor an expression. Right. Now, there are 3 different, well, technically 2 different forms of a trinomial that we're going to be able to factor in this assignment. One looks like this with this is a single variable. So degree 2 polynomial a degree 2 polynomial with a single variable. So looking like this, x squared, or whatever the variable is, squared, there's your degree 2 term, plus, and then some number b times x to the first, right? That's it. B is a number, right? B is some constant like 2 or 3 or something. And then plus c. Right, so we'll see trinomials like this, or we'll see trinomials that are degree 2 polynomials, but with 2 variables. So again, another degree 2 polynomial, a quadratic polynomial, but with 2 variables. So it's going to be like, the first term will be x squared, or some variable squared, plus, and then some number, again, b and c, and I'll write this at the bottom. B and c are just constants. They represent real numbers, they're just coefficients, times x times y, right? So there's another degree 2 term, plus, and then c times y squared. Another, so again, a very specific kind of trinomial where there are 2 variables, but every single term is degree 2. So that's we call it a degree 2 polynomial. And this is a degree 2, a degree 1, and a degree 0, but still overall would be called a degree 2 polynomial. And again, b and c are real numbers, or just representing some numbers. Okay, so how we're going to factor these. All right, how we're going to factor these is the following. Well, first, if there's any greatest common factor to all 3 terms, you pull that out. But for most of these problems, that's probably not going to be the case. So what we're going to do with these particular trinomials is the following. You're going to find a pair of factors, and this is only when the lead coefficient is 1. You're going to see in the next assignment, section 7.3, we're going to look at these same trinomials, but the lead coefficient is going to be, a. It's going to be some number other than 1. And we'll have to do a little more work to factor it. But for right now, when the lead coefficient is 1, like this, we're going to find a pair of factors let's say I call them m and n. We're going to find a pair of factors of c, so that coefficient on the last term, c, cy squared c, we're going to find a pair of factors of c whose sum is b, right? The middle coefficient, the coefficient of the second term. So I want m times n to be equal to c, and at the same time m plus n to be equal to b, right? So I'm looking for numbers m and n that make this happen, these two things happen. M times n is this last coefficient, and m plus n is the middle coefficient. And then the factoring is simple. If you find this m and n, the x squared plus bx plus c will simply factor to x plus m times x plus n. And that's it. There's your factorization. But with the 2 variables, you got to just throw the other variable in there. X squared plus bxy plus cy squared, this will factor to x plus my, right, just throwing a y on the m, times x plus ny. And just throwing that second variable on the second term of each of these factors, and that's it. Once you find this pair of factors whose product is c and whose sum is b, you can jump right to the factors, right to the factorization of the polynomial. It's very simple when this lead coefficient is 1. Right, like I said, when the lead coefficient is not 1, we'll have to do a little extra work, but that's in the next assignment. All right, and then one note about this as well, if this pair of factors cannot be found, right, if this pair of factors cannot be found, then we're going to simply say the polynomial is prime. Then the polynomial, these special trinomials, is prime. All right, remember, prime numbers can't be factored any further. And I would say prime over the integers, but I'm not going to get into the whole over the integers and what all that means. Just say it's prime. It can't be factored any further. And again, that's just a little side note. I'm guessing, based on the fact that this is an assignment where they're introducing this to you, that we'll be able to find these factors. All right, and that's it. Okay, that's it. So x squared plus bx plus c, or x squared plus bxy plus cy squared, a degree 2 polynomial with a single variable or two variables that are trinomials with a lead coefficient of 1. These very specific trinomials, if you can find a pair of factors whose product is c and sum is b, you can factor these pretty easily, like I have here. Right. Okay. So the first example I'm given, right, the first question is on the one with two variables, right, this trinomial degree 2 polynomial with two variables, trinomial lead coefficient is 1, but instead of x and y, it's, r and s are the variables. But I'm doing the same stuff, the same procedure. Right. Right, so that first example I'm given, r squared plus 9 times r times s plus, and then 20s squared. Right, this is in that second form, right? The trinomial with two variables, lead coefficients 1, right? So the value of b here is positive 9, right? It's the coefficient of this second term, this rs term, where both variables are to the first power. The value of c is positive 20, the coefficient of this last term where the second variable is squared. Right, and like I mentioned, we are trying to find a pair of factors of c whose sum is b. Right. So back here, I want to find factors of 20. Find factors of 20 whose sum is 9. So we could do this. All right. Now, if you already know what they are, just use them. But sometimes I'll make a table like this. Here are some factors of 20 and their sum. Right. So write down two numbers that multiply to be 20, and then what do they add up to? And since the sum needs to be positive, I'm going to use two positive factors, right? Because two negative factors will also multiply to be positive, but they won't add up to be positive, right? So I'm using two positive factors. So how about 1 times 20? Right? 1 times 20 is 20, but they add up to 21. Right? So that's no good. Right? Cross that out. Then 2 times 10. I just kind of work my way up from 1 to 20. 2 times 10 is 20. Those add up to 12, which is not 9, right? So those aren't any good either. 3 doesn't go into 20, 4 does, right? 4 times 5. And hey, here it is. 4 plus 5 is 9. So these are the factors. These are the m and n that I was talking about, right? Say m equals 4 and n equals 5. Right, these are the factors that I was talking about, right? Their product is c and their sum is b. their product is 20, their sum is 9. And since the lead coefficient is 1, we can jump right to, r plus ms times r plus ns. Right? R plus 4s times the other factor will be r plus 5s. And that's it. There's the factorization of that polynomial. And that marker is getting pretty faint. Now, if you want to check your work, remember how to, I mentioned this in section 7.1's assignment. The way you check if your factoring is correct is by multiplying. If you were to multiply r plus 4s by r plus 5s, distribute the r, distribute the 4s, you'd get r squared plus 5rs and then plus 4rs, making plus 9rs when you combine like terms, and then plus 20s squared. So multiplying these two gives me the original back. So this works. That is the correct factorization. And that's how you check any factorization. Again, you check it by multiplying it out and seeing if you get the original expression again, which I do here. All right, so back on the assignment, that's what I'm going to type. Right? We're asked to factor this. The two factors are r plus 4s times r plus 5s. Or r plus 5s times r plus 4s. Same thing. And you see they make the same kind of a table here. Great. Alright, so I'm basically been doing the same thing for all these problems. Right. So here's another one with two variables. Again, the variables are r and s instead of x and y, but you still go about the same business, the same procedure. Alright, so let me take out another sheet here. Alright, so this one, we have again r squared. The middle term is plus 6rs, and then plus 8s squared, right? It's in that second form, that second special trinomial with a lead coefficient of 1. And again, since the lead coefficient is 1, this should be pretty simple. Right? The value of b is positive 6. The value of c here is positive 8. So I'm trying to find, and I'm not going to write this out every time, just for these first couple examples. I'll say it after this. But I'm trying to find, factors of 8. Factors of 8, two numbers that multiply to be 8, whose sum is b, whose sum is positive 6. Right, and I'll make that little chart again, that little table. We'll look at pairs of factors of 8 and their sum. Now again, this is a positive 8, so the two factors could be positive or they could both be negative. But if I want the sum to be positive 6, then I'm going to be needing positive factors. Alright, so how about 1 and 8? Right, those multiply to be 8, but they add up to be 9, which is not 6. Right, so that's no good. Then kind of moving up, 2 goes into 8, right? 2 times 4 is 8, and aha, there it is. 2 plus 4 is 6. So these are the two numbers that I want to use, 2 and 4. And again, if you want to call them m and n like I did earlier, m is 2, n is 4, go ahead, but I'm going to stop doing that after this as well. But once you find those factors, factoring the polynomial is going to be simple now. Again, if it's in one of these special trinomial forms with a lead coefficient of 1, this will factor to r plus 2s times, and then the other factor is going to be r plus 4s, right, using the other factor of 8. And there we go. This is it. This is all they want. write your polynomial here as a product, right? Factor it. And please don't forget to check, right? Multiply these. You'd have r squared, then plus 4rs plus 2rs for plus 6rs, and then plus 8s squared. So it does check out. That is the proper factorization. It is equal to the original expression. So the quantity r plus 2s times r plus 4s. And again, you can have the factors in either order, any order you wish. You could put this as r plus 4s times r plus 2s, and it would be the same thing. All right. Great. All right, so now we're to the single variable trinomials of these forms, x squared plus bx plus c. But this is where c is negative, right? But still the same procedure is going to happen here, but there's only going to be one variable. All right, so we're in this first case I wrote up. Right. So the polynomial I have here is, instead of x, the variable is d, right? They're asking us to factor d squared plus 6d, and then the constant term is minus 27. Right? This is in this form, x squared plus bx plus c, where b is the coefficient of the first powered term, positive 6, and the value of c is the constant term, right? Minus 27 is really plus negative 27, so don't forget the negative signs with your values here. All right, so c is negative 27. And then just as I've been doing, I'm trying to find factors, find two numbers, find a pair of factors of c, right, of negative 27, whose sum is b, right, whose sum is positive 6. And then once we find those, the factors, because the lead coefficient is 1, the factors will be just d plus one of them times d plus the other one. Right? It's very, very simple when the lead coefficient is 1. Right. Now this time though, it's a little trickier because the value of c is negative. Right, when I make my little, you can make the chart again. Now if you already know the factors, you don't need to make the little table. Here's factors of negative 27 along with their sum. Now if the two numbers need to multiply to be negative 27, that means one has to be positive and one has to be negative. But I want their sum to be positive. Alright, so when I have a negative number and a positive number, and I want the sum to be positive, the positive number has to have the larger magnitude. So like negative 1 and positive 27, right? I would want to use that pair instead of negative 27 and positive 1, because those would have to be a negative number. I want the positive factor to be have a larger absolute value or a larger magnitude. That way when I add them, it's a positive number, right? Negative 1 plus 27 would be positive 26. But that's not good, right? That's not adding up to positive 6. Then 2 doesn't go into 27. 3 does, right? Negative 3 times positive 9. Right? That'd be negative 27. And oh look, these add up to positive 6. Negative 3 plus 9 is positive 6. And so these are the factors I want. And like I said, once you find that pair of factors, negative 3 and positive 9, factoring these trinomials, these degree 2 trinomials with a lead coefficient of 1, is very simple. One factor is going to be the variable plus one of these, so d plus negative 3, but d plus negative 3 you can write as d minus 3 times, and then the other factor is going to be d plus the other one, d plus 9. And that's it. There's our factorization of that expression. And once again, check it out. Multiply these, and you should get d squared plus 6d minus 27 back. D times d is d squared. D times 9 is 9d Negative 3 times d is negative 3d. 9d minus 3d is 6d. And then negative 3 times 9 is negative 27. This is the correct factorization. It gives me the original polynomial when I multiply them. Okay, so the d minus 3 times d plus 9, or d plus 9 times d minus 3. It doesn't matter what order you put the factors in. Now you see they're going through each pair. Like, I don't like this. You know, do some thinking. You know, see how they go through the negative 1 and 27. How about 1 and negative 27? Well, no. I mean, you want them to add up to positive 6. So just have it where the positive factor is bigger. You know, you don't have to check the other one because it's just going to be the opposite sum. I don't like that they're going through all those like that. Anyway, moving on. All right, so another one, same objective here, where you're looking at one of those special trinomials with one variable. Again, lead coefficient of 1, so should be simpler than most things. But this, you know, instead of having the variable x, you have the variable. Now this is going to be confusing maybe, but the variable is c. All right, so maybe I'll call this c, and then I'll put a little slash to it. Like there's, you know, c squared plus, and then 66 times c, again with the little slash. These are the variable c's, minus 67. The value of b is positive 66. And then the value of c, the constant c, that's why I threw the slashes through the other ones, is negative 67. Alright, so I'm hoping you can see this. Again, after a bit of practice here, you might get the hang of this. But the factors I'm looking for here then are, you know, I want one positive and one negative factor, right, because they need to multiply to be negative 67. But I want the positive one to have a larger magnitude because they need to add up to positive 66. So negative 1 and positive 67. I mean, these are the factors I'm looking for, right? They multiply to be negative 67. They add to be 66. Right? And now that I've got those, I can easily factor it. Since, again, the lead coefficient is 1, it's just going to be that variable c minus 1 times that variable c plus 67. And again, that's all. That is all. And again, you can check it by multiplying. Make sure you get the same expression, the original expression back. But yeah, so here it's c minus 1 times c plus 67. Okay. Alright, so now where the value of c is positive, another one of them special trinomials with a lead coefficient of 1, but where the value of c, the constant term, is positive. So, you know, I'm just going to do this here. So we have c, variable c squared minus 11 times the variable c plus 30. So again, the value of b here, the coefficient of the first powered term, is negative 11. And the value of c, the constant c, is positive 30. Alright, so I'm looking for factors of 30, and this one I'll make a chart for because it's the first time we've seen a negative b. I'm looking for factors of positive 30 that add up, that have a sum of negative 11. So remember, this is a positive number, so the factors need to either be both positive or both negative. Right? Now, if they're both positive, they're going to add up to a positive number, which I don't want. I want the sum of negative 11. So I'm going to use both negative factors, so negative 1 and negative 30. Right? Those multiply to be positive 30, but they add up to be negative 31. Right? So those aren't good. I want negative 11. How about negative 2 and negative 15, right? Those multiply to be positive 30, but they add up to be negative 17, not negative 11. Negative 3 and negative 10 multiply to be positive 30, but those add up to be negative 13. We're getting closer to negative 11, but it's not negative 11 yet. Then 4 doesn't go into 30, 5 does, right? Negative 5 times negative 6 is positive 30, and those add up to negative 11, and these are what we want. So this would factor to, variable c minus 5 times variable c minus 6. And that's it. All right, c minus 5 times c minus 6 would be equal to c squared minus 11c plus 30. And once again, you can check it by multiplying, which it should work. C minus 5 times c minus 6, or c minus 6 times c minus 5. Either way. Okay. So same objective here. So once again, I'll write this out, and then I think after this, I might just talk it out, because a lot of these after you get the hang of it, should be relatively simple. So we have u squared minus 14u plus 45, right? This is another one of them special polynomials, special trinomials with a lead coefficient of 1. And I'm just looking for factors of 45 that add up to negative 14. So I'm hoping you understand that those factors are negative 9 and negative 5. Those multiply to be positive 45, and they add to be negative 14. So this will simply factor to u minus 9 times u minus 5. And that's it. And again, you can check it by multiplying, but it should work out. So u minus 9 times u minus 5. And again, you can put it in any order you want. U minus 5 times u minus 9 would also work. Okay. All right. So now I'm just going to kind of talk them out, especially the smaller number ones like this. The factors of positive 18 that have a sum of negative 9 would be negative 3 and negative 6. Right? Negative 3 times negative 6 would be positive 18. Negative 3 plus negative 6 would be negative 9. So this will factor to z minus 3 times z minus 6. And that's it. And again, you can check by multiplying. Another one, y squared minus 15y plus 56. Again, it's in one of those special trinomial forms with a lead coefficient of 1. So the factors of 56 that add up to negative 15 would be negative 8 and negative 7. Negative 8 times negative 7 is positive 56. Negative 8 plus negative 7 would be negative 15. Right? So this would simply factor to y minus 8 times y minus 7, or y minus 7 times y minus 8. And again, you can check by multiplying. Okay. So back to one of these, r squared minus 6r minus 16. All right, so the factors of negative 16 that would add up to negative 6 would be negative 8 and positive 2. All right, negative 8 times positive 2 would be negative 16. Negative 8 plus 2 would be negative 6. And because the lead coefficient is 1, I can just jump right to the factors very quickly. R minus 8 times R plus 2, right, using negative 8 and positive 2. Or R plus 2 times R minus 8. And check by multiplying if you want. Okay. So one more of these with one variable, v squared plus 1. Now, if there's no coefficient, remember the coefficient is positive 1, is 1, right? So this is v squared plus 1v. The value of b is 1. And then the value of c is minus 90, negative 90. All right, so the factors of negative 90 that add up to positive 1 are negative 9 and positive 10. Right, negative 9 times 10 would be negative 90. Negative 9 plus 10 would be positive 1. And because the lead coefficient is 1, I don't need to do any extra work. This is just v minus 9 times v plus 10. Right, using the negative 9 and positive 10 that I stated earlier. Or v plus 10 times v minus 9. Great, and then we got a couple more with the two variables. Again, all I'm doing is adding the second variable to the second term of each factor. Still doing the same procedure. So here I have b squared plus 15bc plus 56c squared. So again, it's in that one of those special forms like in the objective here with a lead coefficient of 1. So all I need to do is find factors of 56 whose sum is 15, and that would be 8 and 7. So this would factor simply to b plus 8c times b plus 7c. Just don't forget to add that, the second variable, into the second term of each factor here. b plus 8c times b plus 7c. Wonderful. And just one more of those. So here we have p squared plus 20pq plus 75q squared. Again, it's in that special form of a trinomial with a lead coefficient of 1 that we had here for all these problems. So I just need to find factors of c that add up to b. All right, factors of 75 whose sum is 20, and that would be 5 and 15. 5 times 15 is 75. 5 plus 15 is 20. So this will factor to p plus 5q times p plus 20q, or p plus 20q times p plus 5q. And again, you can check by multiplying, see that it's the original. Oops, I said 20. I said 15, didn't I? I said 15. I said 5 and 15, and then I typed 20. That should be p plus 5q times p plus 15q. Sorry about that. I typed something that I didn't say. So yeah, there's a typical lesson there for you. Don't rush things. Check your work, right? And if you were to multiply these, if you took p plus 5q times p plus 20q, it wouldn't give you this. You'd have 100q squared, not 75q squared, so they wouldn't be the same. So that's another way I could have told myself that was wrong. Yeah, I said 5 and 15, right? 5 times 15 is 75. 5 plus 15 is 20. Okay. Yeah, so again, sorry about that. A little quick error there. And that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I see here may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same, and the structure should be similar. The way you go about doing them should be similar. So I'm hoping that watching me do these here or listening to me do these here help you in some way when you work on the assignment on your own. All right, and thank you very much for watching.